video is about the rule of Pythagoras continued, some more application problems of the Pythagorean theorem. To remind you what the Pythagorean theorem is, states that in a right-angled triangle, where the hypotenuse is C and the legs are A and B, it's true that C squared equals A squared plus B squared. So if you add up the sums of the squares of the two legs, it equals the square of the hypotenuse. So here's an example that goes beyond what we did in class. It doesn't give you two of the sides. It gives you that one of the legs is x, the other leg is 6, and the hypotenuse is 2x. This is enough information for us to determine what x is. So it's going to ask us to solve for x. We're going to start with the Pythagorean theorem. We can use it because it's a right triangle. We know that. It shows us the little box in the corner. A and B are the legs, so I can replace A with x, and I can replace B with 6. C is the hypotenuse, and I'm going to replace it with 2x. It's very important that you replace that in parentheses. On the left, there's nothing for me to simplify here. 6 squared is 36. On the right, when I simplify 2x quantity squared, the whole thing to the second power, it's 2x times 2x, which is 4x to the second power. So I'm going to pull that down here. Then I'm going to solve this equation algebraically, get my x to one side, and we'll subtract this x squared. 36 equals, these are like terms. This is 4x squared minus 1x squared, which is 3x squared. I can solve this equation first by dividing by 3. 36 divided by 3. 12 equals x squared. And then I'm going to solve for x by square rooting both sides. When I square root, it's plus or minus, but I am going to throw away the negative answer because distances are positive. So the square root of 12 equals x, and then I just want to put this in simplest radical form. So 12 breaks into 4 and 3. 4 has a square root. 3 does not. And that's the solution for x in simplest radical form. Another extension, so find the value of any unknowns. Now it's asking us to find x and y as part of the same problem. And I see two different right triangles here. I'm not going to be able to find x and y at the same time. And in fact, I'm not going to be able to find y at all until I've found x. So in this problem, I can see in this triangle up here, triangle ABC, I have enough information to figure out x. That triangle gives me the 5 centimeters and the 1 centimeters as the two legs, and x as the hypotenuse. So I'm going to start in that triangle by finding x. A squared plus b squared equals c squared. A is 5 and b is 1, or vice versa. It doesn't matter which leg you use as a or b. In fact, I should replace c with x, since I'm solving for x. 5 squared is 25, 1 squared is 1. 26 equals x squared, and so x equals the square root of 26. Nothing's going to go into 26 that has a square root, so I'm going to leave that. It's as simple as it gets. And now that I know that this length, where the x is the square root of 26, now I have enough information in the triangle ADC to figure out what y is. So y and the square root of 26 are the legs there. 6 centimeters is the hypotenuse. I can see that because it's across from the 90-degree angle in the triangle ABC. So that makes this the hypotenuse, and the other two sides the legs. So when I do this Pythagorean theorem, A is going to be y squared. B is going to be the square root of 26 squared. And then c squared will be 6 squared. So the unknown here is y. The square root of 26 to the second power, the root just lifts off, and 6 to the second power is 36. Subtract 26 from both sides. Y squared equals 10, so y equals the positive square root of 10, which cannot be simplified either. So these are the answers for x and y in simplest radical form. And then one more extension. Again, it's two triangles, but this time, or two right triangles, I should say. This time it's a smaller right triangle, which is ABC, right here, nested inside of a larger right triangle, which is ABD, okay? And that's right there. I don't care about the triangle ACD, which would be this triangle here, for right now because it's not a right triangle. And this is about the Pythagorean theorem, which I can only use for right triangles. So I don't care about that blue one that I just shaded in. I care about the right triangle ABC and the right triangle ABD. I have AB, the length from A to B, okay, and I have the length from A to D. Which means in the outer triangle ABD, I actually have enough information. I have two of the sides, and I know that it's a 90-degree angle right here in the corner. So I have enough information to get this whole length. I'm going to start by doing that. So that's the first application of the Pythagorean theorem that I can actually use in this problem. I've got one of the legs is 4, the other leg I don't know, and the hypotenuse of that triangle, the outer triangle, is 9. Subtract 16 from both sides. It's going to be 65. And then square root both sides, just like so. Now that I know this whole length is the square root of 65, and I can't simplify that at all, I can use that to find this length right here. Because I know that this has this little tick mark and this has the same little tick mark, I know that those two lengths are equal to each other. If the whole thing is the square root of 65, then each piece is half of the square root of 65, or root 65 divided by 2. Which finally allows me to go back into this small triangle here and find what it wants me to find. So if you look back at the original question, it wanted us to find the length of AC, which is this hypotenuse here. So in order to get that hypotenuse, I'm going to need to use the two legs from that small triangle, which I now know. For a squared, I can reuse the 4. For b squared, this time I'm going to use this root 65 over 2. And c squared is the hypotenuse, which I don't know. Simplify this. The square root of 65 times the square root of 65 is just 65. And 2 times 2 is 4. To add these two things together, I'm going to need to get a common denominator. So I want to put this over 4, which means the top is becoming 16 times 4, which is 64. So I've got 64 fourths plus 65 fourths equals c squared. 64 plus 65, 129 fourths equals c squared. And then I'm going to square root both sides. So c will equal the square root of 129 over 2. And that's the length of AC, which is what it was asking us for to begin with. And that is all.